Right now, the United States is running two completely different disasters off the same weather system, and most people can only see one of them. Across the south, a dome of high pressure is holding temperatures above 100 degrees, with almost no overnight relief. Texas and Oklahoma are sitting in triple digits again today. 900 miles north, the same system is generating rounds of severe thunderstorms and flash flooding across the Midwest, and the Weather Prediction Center has the heaviest rain aimed at Iowa, western Illinois, and southern Wisconsin. Same pattern, same cause. Two opposite emergencies, depending on which side of the line you live on. But here is the detail that tells the real story, and it is the one nobody is putting on the front page. The Atlantic Ocean is empty. In the middle of what should be peak hurricane season, this is the quietest start to an Atlantic season this century, by one common measure: 2 named storms, no hurricanes. One of them, Bertha, held its name for roughly 72 hours before it fell apart. And that silence is not luck. It is being enforced by the same global engine that is holding the heat dome in place over your country. So in this video, I want to do something specific, not a list of scary numbers. One system, traced from the Pacific Ocean to the roof of your house, so that by the end, you understand exactly which of these threats actually applies to where you live, and which one you can stop worrying about. Because there is a version of this story going around that says the quiet Atlantic is a bomb waiting to go off. That version is wrong, and I am going to show you why with the actual sea surface data. Start with the thing everything else hangs off: a heat dome. The name makes it sound like a blanket of hot air that drifted in from somewhere. It is not. A heat dome is a mound of high pressure in the upper atmosphere, and what makes it dangerous is not that it holds heat in. It is that it forces air downward. When air sinks, it compresses. When it compresses, it warms. So the dome is not trapping heat that was already there. It is manufacturing new heat, continuously, for as long as it sits still. Sinking air also kills clouds. No clouds means nothing between the ground and the sun, which heats the surface faster, which feeds the whole process. It is a loop that reinforces itself, and it is why heat domes tend to break records, rather than just make hot days. Right now, that ridge is anchored across the south and southeast, and forecasters have it building west into the southwest through this week. And here is the part that gets skipped in almost every piece of coverage on this. It is not one dome, it is two. A separate ridge is building over the western United States, and its effect there is different. It is suppressing the North American monsoon, the seasonal rain the interior west depends on in late summer. A few storms will still fire, but much of the interior west stays rain-free under it. There is a difference between an air temperature and a feels-like figure. 115 as an air temperature is an extraordinary reading. 115 as a heat index, air temperature combined with humidity, is a bad but far more common summer afternoon across the Gulf states. Those two numbers are not the same claim, and when a video blurs them, everything else it tells you is worth less. What is actually happening this week is triple-digit air temperatures across Texas and Oklahoma, dangerous heat holding across the south and southeast, and this is the number that matters most: very little overnight relief. That last one is the killer, and it gets the least attention. Your body handles a hot day by recovering at night. Core temperature drops, cardiovascular load eases, you reset. Under a heat dome, the overnight low stays elevated, so that reset never happens. Day 3 of a heat wave is more dangerous than day 1, not because the afternoon is hotter, but because you started it already depleted. That is why heat is, in most years, the deadliest weather in the United States, ahead of tornadoes, hurricanes, and floods. Not because any single afternoon is lethal, but because it accumulates, indoors, quietly, mostly among people who are old, alone, or without working air conditioning. Here is where the pattern turns from a heat story into a severe weather story, And the mechanism is worth 2 minutes of your attention because it explains almost every summer storm outbreak you will ever see. The dome is a mound. The jet stream, the fast river of wind high in the atmosphere, cannot go through it, so it goes around, riding along the northern rim. That rim is now the most active piece of atmosphere on the continent. On one side, you have the dome pumping heat and Gulf moisture northward. On the other, you have cooler, faster air arriving from the northwest, and a boundary between two air masses that different is not a line on a map. It is a machine. The Storm Prediction Center's extended outlook has that ridge expanding from the four corners into the southern plains, with northwest flow running over the northern plains and shifting east across the Midwest and toward the northeast. That sentence is unglamorous. It is also the whole forecast. It tells you exactly where the rim is, and therefore exactly where the storms will be. This week, that has meant severe storms across the Central Plains, a severe threat through the mid-Mississippi Valley, and a cold front sagging from the Great Lakes down into the Central Plains, firing storms along the Missouri and Ohio River valleys. Now, a word about how these risks are actually communicated, because if you learn one thing from this video, make it this. The Storm Prediction Center rates severe weather on a 5-level scale: marginal, slight, enhanced, moderate, high. Most of the country never sees a level 4 or 5 in a given year. A level 1 or 2, marginal or slight, does not mean nothing will happen. It means storms will be isolated or scattered rather than widespread. People routinely read a level 2 as an all clear, and a level 2 day is exactly the kind of day that produces one destructive storm over one town, while the rest of the state has a nice evening. One more thing about the storms on this particular rim. Because the flow aloft is coming from the northwest, storms tend to organize into long lines rather than isolated rotating cells. That shifts the main threat away from tornadoes and towards straight-line wind, damaging gusts driven along the leading edge of a line. Straight-line wind is badly underrated. It can match a weak tornado for damage. It hits a far wider area, and it arrives with no siren because there is nothing rotating to warn you about. If this is the kind of breakdown you want in your feed, the next time a pattern like this sets up, subscribe. That is the whole pitch, and I will not mention it again. The third consequence of this pattern is the one that will probably do the most damage, and it is the one that photographs the worst. When the rim of a ridge sits in roughly the same position for days, storms do not just form there once. They form there, move along the boundary, and are replaced by more storms following the same path. Forecasters call it training, storms running over the same ground like train cars over a stretch of track. This is the difference between a rain total and a flood. 4 inches of rain over 2 days is a wet week. 4 inches in 90 minutes, on ground already saturated from the night before, is water in basements and cars floating off roads. This week, the Weather Prediction Center has flagged heavy rain and flash flooding across the Midwest, with the heaviest totals aimed at most of Iowa, western Illinois, and central and southern Wisconsin. And the risk levels there have been mostly marginal to slight, levels 1 and 2 on a 4-point rainfall scale. Which brings me back to the same point I made about storms, because it matters more for flooding than for anything else. Flash flooding is the disaster that kills people at level 2, not because the forecast was wrong, but because the danger is so local. A slight risk across 6 states can still mean one creek in one county rising 4 feet in 20 minutes. And the majority of flood deaths in the United States happen in vehicles, not in houses, in cars, on roads people drive every day, in water that does not look deep from the driver's seat. 6 inches of moving water is enough to make you lose control. 12 will float most cars. 2 feet will move a pickup. And you cannot judge any of that through a windscreen at night, because you cannot see whether the road under the water is still there. If you take one behavioral change from this entire video, make it that one. A flooded road is not a shortcut. Turn around. Now, the part of this pattern that is genuinely strange and the part where I want to correct something that is circulating widely. It is the third week of August. The Atlantic hurricane season is supposed to be accelerating toward its September peak. On an average year, the third named storm has already formed by the 3rd of August. Instead, 2 named storms all season, Arthur and Bertha, both short-lived, both along the Gulf Coast, neither reaching hurricane strength. No hurricanes at all so far this year. The reason sits about 4,000 miles away, in the Pacific Ocean. El Niño conditions emerged in the equatorial Pacific in June, and NOAA has put the odds of a strong or very strong El Niño through August, September, and October at 90%. El Niño is a warming of the central and eastern Pacific, but it does not stay in the Pacific. Warmer water there changes where the biggest thunderstorm clusters on Earth sit, and moving those clusters bends the circulation of the entire tropical atmosphere. One of the downstream effects lands directly over the Atlantic as increased wind shear. Wind shear is simply wind changing speed or direction with height. And this is the detail I find genuinely elegant about how the atmosphere works, because shear does 2 opposite things depending on where you put it. Over the Midwest, shear is what turns an ordinary thunderstorm into a rotating supercell. It tilts the storm, so its updraft and downdraft stop canceling each other out, and the storm survives long enough to organize. Over the tropical Atlantic, the same shear does the opposite. A hurricane needs a vertical stack, a chimney of rising air, lined up from the sea surface into the upper atmosphere. Shear pushes the top of that chimney sideways, and the structure comes apart before it can consolidate. Same physical process. Builds one storm, destroys the other. That is why this summer has both an unusually violent Midwest and an unusually empty Atlantic. Which brings me to the claim I said I would correct. You may have seen the argument that because no storms have churned the Atlantic this year, heat has been piling up in the ocean unspent, and that whenever the shear finally relaxes, a storm will tap all that stored energy and explode into a monster. It sounds compelling. It is not what the data shows. Sea surface temperatures across the eastern and central tropical Atlantic have been running slightly cooler than normal this season, not hotter. The western tropical Atlantic is warmer than normal, but the main development region, the stretch of ocean where African waves normally grow into hurricanes, has not been building some unusual reservoir of heat. And shear is not even the only suppressor. Dry, dusty air off the Sahara has been widespread across the tropical Atlantic for weeks. Dust and dry air starve a developing storm of the moisture it needs. That is a second, independent break, and it is nothing to do with stored heat. So the honest version is less cinematic and more useful. The Atlantic is quiet because the atmosphere above it is hostile, and the air feeding it is dry. And NOAA now gives this season a 75% chance of finishing below normal. 7 to 13 named storms, 2 to 6 hurricanes, 0 to 2 majors. And yet none of that means the coast is safe. Here is the real reason, and it is stronger than the myth it replaces. A below normal season is a statement about the count. It says nothing about the track. Seasons with very few storms have still produced landfalling hurricanes that did enormous damage, because a coastline does not experience a season. It experiences the one storm that arrives. Suppressed odds are not zero odds, and a quiet basin does not lower the water in a storm surge. The National Hurricane Center is already tracking a new area of interest off the coast of Africa. As of today, it carries roughly a 20% chance of development over the next week. That is low. It is not nothing. And it is the first thing out there in a while that is worth a second look. So, one system. Let me put the whole thing back together in 30 seconds. A ridge of high pressure over the south forces air downward, manufacturing heat and killing cloud cover. A second ridge over the west does the same thing there and shuts down the monsoon, deepening drought. The jet stream is pushed around the northern rim of the southern dome, and along that rim, heat and moisture collide with cooler air, producing daily rounds of severe storms. Those storms repeat over the same ground, which turns a rain forecast into a flood risk. And 4,000 miles away, the El Niño, driving the shear that is holding the Atlantic empty, is part of the same global circulation. So what applies to you? If you are in the south or southeast, the heat is the threat, and the overnight hours are the part to take seriously. Find somewhere air-conditioned for a few hours a day if your home does not hold it. Check on someone who lives alone. Never leave a child or an animal in a parked car. An interior can reach lethal temperatures within minutes, and it does not take a record-breaking day. If you are in the interior west, this is a fire weather pattern, not a storm one. Dry ground, suppressed monsoon, sustained heat. Know your evacuation route before there is anything to evacuate from. If you are in the Midwest, the Great Lakes, or the Ohio Valley, check the SPC outlook for your county each afternoon, rather than reading a national headline. Expect straight-line wind ahead of tornadoes. Have phone alerts switched on, and know which room in your house you would go to. If you are in the Iowa, Illinois, Wisconsin corridor, the flooding is the one. Watch the ground, not the sky, and do not drive into water. If you are on the Atlantic or Gulf Coast, nothing about this quiet season changes your plan. The count is low. The exposure is unchanged. And one last thing, because I would rather be useful than sound certain. The heat and this week's storms are high confidence. The exact flood totals are not. The African wave is a 20% chance, which means 8 times out of 10, it becomes nothing at all. Forecasts are not predictions that get graded right or wrong. They are a picture that sharpens as you get closer. The value is in checking again tomorrow.